Hello everyone, and welcome to Tourism Mhlongo's Maths and Science and Physical Sciences YouTube channel. Today we're going to be looking at Analytical Geometry from grade 11, and that's the November 2016 paper 2. This question is still applicable to grade 12 learners in question 3, grade 12. But in grade 11, this would be a question 4 or question 3 also. So, in the diagram below, point R and point A are the x and y intercept of a straight line given AR, or called AR with the equation y is equal to minus a half x plus 4. And then there's another straight line that cuts through the y-axis at point P and point M, whereby point M is k is to 0 and n is 3 is to 0. The angle alpha and angle beta are the angles of inclination of the lines MN and AR respectively. Now we are given that M, P and N are collinear. Then we have to calculate the value of K. Now M is this point, K is to 0, P is this point, 0 is to 2, and N is the point 3 is to 0, and all of them are collinear. Now points that are collinear are something like this: points that are on the line, in one line, and they have equal gradient, which means if this is M, as we can see from the question here, it's M, P and N. So M, P and N, which means the gradient of this and the gradient of this and the gradient of this will be equal. So now we need to calculate those two gradients. Let's start with the gradient of Pn. So Mpn is given by y2 minus y1 over x2 minus x1. Now if we're looking at Pn, I always advise learners to rewrite the coordinates that they are working with and label them as x1, y1, so that you just plug and play x2, y2. So now our x2 here, it's a 0 minus 2 all over 3 I think I made a small mistake here with my points. Point N is not 3 to 0, it's 3 to 4. So excuse me for that. Say 3 to 4. 3 to 4. And then, so we put 4 here. So 4 here, 4 here, and a 4 here. So that gives us a 3 minus 0. And then 4 minus 2 is a positive 2 all over 3. Now that we have the gradient of Pn, we have to calculate the gradient of Mp, whereby this is k is to 0 and 0 is to 2. Labeled x1, y1, x2, y2. Now y2 minus y1 over x2 minus x1, which is equal to 2 minus 0 over 0 minus k over 0 minus k. Now this gives us a 2 over negative k. But we know that the gradients are the same, so the gradient of Pm is equals to the gradient of Np. Now this is 2 over negative k. is equals to 2 over 3, which then gives us a what? A 6 is equals to negative 2k, and then we divide by negative 2 on both sides, and we find that k is equals to negative 3. So we have the value of k, which means now we have the value of point M. Now we want to calculate the size of angle theta. But we see something here. So the triangle that has angle theta is something like this. This is theta, this is alpha, and this is beta. What do you know about it? And a triangle like this? We know that if we say theta plus alpha, this gives us beta because of the exterior angle of a triangle. So keep that in mind. The first thing we're going to do is to calculate the gradient of alpha using what? The gradient of Pn. Now, we already have the gradient of Pn. So in 4.2, we just say Pn is equals to 2 over 3. And we know that tan, it's not tan theta, it's tan of alpha, because that's the gradient, that's the line in which the gradient Pn is in, and that's the angle alpha that it makes with the x-axis. Tan alpha is equals to the gradient of Pn. Now alpha is equal to arctan of 2 over 3, which is equal to a 33.69 degrees. Then we have to get our angle beta, which is from the equation of AR. Y is equals to negative 1 over 2x plus 4. Therefore, its gradient of AR is equals to negative half. So, are we calculating the gradient or the angle beta? No, we're not. We have to first calculate its reference angle, because that is a negative angle. So, and the negative angle where tan is negative is in 180 minus. So, what do we do here? We have to say that tan beta is equals to the gradient of AR. Now, tan beta is equals to negative half. And then now we calculate the reference angle as if we were calculating a general solution, is equal to arctan of 1 over 2. So we ignore the sign when we're calculating general solution. The reference angle will be equal to a 26.57 degrees. Now, beta will be found in the beta is an angle that is greater than 90. So if we say 180 minus the reference angle, we find beta. So this is 180 minus 26.57 is equals to a beta. Now beta will be then equal to 153.43 degrees. Now remember, we gave this equation that says theta plus alpha is equals to beta. Now we're looking for theta, which is equals to beta. minus alpha, and you calculated beta to be 153.43 degrees. Then we subtract our alpha, which we found to be 33.69 degrees, and then we get that theta is 119.74 degrees. Okay, then you get your marks just like that, and calculate the length of MR. Now we already got K. Let me go back to the question. I cannot scroll through this picture. Calculate the length of MR. Remember that we calculated K here, and R is a point in the straight line of AR, which is the what? The x-intercept. Now, x-intercept, we let y be 0. So we first have to calculate the coordinates of R. So in 4.3, we start at y is equals to minus half x plus 4, and at R, y is equal to 0. So 0 is equals to negative half x plus 4. Negative 4 is equals to negative half x. Divide by negative half, divide by negative half. You get that x is equals to a positive 8. Now it means that R is equal to 8 is to 0, while M is equal to negative 3 is to 0. And they said in 4.3 we need to calculate what? We're calculating the length of MR. So we have the 2 now. MR. M is negative 3 is to 0. R is 8 is to 0. This is x1, y1, x2, y2. Then the distance formula to calculate MR is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now this is equal to 0. Oh, that is 0. And 8 minus negative 3 all squared plus a 0 minus 0 squared. Then this gives us it's equal to 11. Last question tells us to calculate the area of MNR. So we have all those three. MNR, so we need to redraw that. It's triangle MNR. MNR. Now, the length of MR we already know, but the length of MN we don't know. So we have to calculate the length of M, which is negative 3 is to 0, and N, which is 3 is to 4. First calculate Mn, which is equals to the square root of x2 minus x1 squared plus y2 minus y1 squared, which is equals to the square root of 3 minus negative 3 squared plus 4 minus 0 squared. And this gives us a 2 root of 13. Now, we have this length, we have this length, and we have this angle here. What is that angle there? The angle there is angle alpha. Angle alpha. Now, this means we can use the area is equals to half ABC, or sine C, which will be half MR times MN sine of angle M. Substituting all of that, we then get half of 11 times 2 root of 13 sine of 33.69 degrees, which is equal to 22 square units. And that's it. Thank you so much for watching our video, and please like and subscribe.